All right, so I need to give you guys a very quick idea before we go do a field trip. So this happens all the time. I kid you not, I used this building my freaking patio this weekend. I know the patio keeps coming up, but it's just because I keep doing Calc 3 while I'm building my patio. So here's the issue. You have some kind of surface, right? Yeah, and I would like to put gravel over this surface, but let's forget that for right now. Let's just say we have a surface. Okay, so I'm going to follow my little corners down. I'm going to make my little grid thing like I usually do. It's going to look like crap because I'm drawing it really fast. Okay, so I have an x direction and a y direction, and some function of x and y. Good? Yes?
Only good.
Okay. We are going to learn integration a la Calc. Cool? This is just the Riemann idea. You guys remember what a Riemann sum is?
Oh, very familiar.
You're all very familiar with Riemann sums?
It sounds familiar.
Okay, so what is the idea of a Riemann sum, and what am I looking for here that might use a Riemann sum?
Chop it up into rectangles and add them all up.
Yes, right? The idea of a Riemann sum is you take the area under a curve, you cut it up into a bunch of frickin' like almost rectangles,
Or anything that
and then you add up the areas, right? Okay, so the Calc 3 version is going to be that I'm going to cut the XY plane up into squares.
Rectangular prism.
Cutting the XY plane, right? So it should be two-dimensional. So I'm going to go from, say, A and B in the X, and like C and D in the Y, right? So I'm going to get some kind of rectangle here. That's going to follow up to some kind of like funny little curve. I ended up drawing this picture twice. How neat is that? Okay? You guys all with me? I want to find out the area underneath this thing. So the way I'm going to do that is I'm going to chunk this into little bits. Right? And I'm going to chunk this into little bits. So we're going to cut in the x direction and the y direction. Yeah? And so then we're going to get some one of those little guys, looks like a little rectangle out here in the domain. And then how much volume is underneath the surface above that rectangle? Yeah, so you'll push that thing up and you'll get some little handkerchief, right? Now I've drawn this thing 3 times. You guys see this? But basically that's a little rectangular prism, right? And so it's going to be naturally kind of delta x in this direction, delta y in the other direction, and so I'm going to say my volume, right, is more or less delta x, delta y, and
The height can change depending on which.
good. So f at you guys remember?
At C.
Yeah, so don't plug in a delta x and a delta y, right? Because those are the change in the x and the change in the y.
It could be.
You need like
C.
some.
B minus A.
Yeah, this should be f of x and y, right?
Yeah.
Except you need to plug in specifically an x and a y that are actually in that thing, right? So you do like xi star, comma, yj star, right? Which is just some special x value that happens to be in the little thing you're talking about, right? So this is like the ith interval x special one. And this is the y that's in the jth interval that's special. You get to pick this. You guys cool with it? Okay, so we're going to run we're going to run outside and we're going to try to figure out how much water was in the lower arboretum last year. I made an estimate of this and it wasn't good because I couldn't see the ground under the water, right? So I didn't know how deep it was. So I just kind of guessed at an average depth. But we're going to go out, and if each of us picks a little spot, right, then we can maybe get some kind of average depth. We'll be able to see where the water was. It would have been even better to do this in the spring last year when there was actually water in it, because I could have you all wade out and stick a pole in the water, right?
Borrow a weight or
You could
something
like
up
go
and
out
down.
and hold your hand up and measure the depth. And we could just kind of measure how far down your hand the water line was, because it was deeper than most of you are tall. Cool? Alright, so let's go figure out how much water was in the lower arboretum. But this is the idea of integration in Calc 3.